Hello, everybody. In continuation of my recent discussion about advances during the last decade, during the last 10 years in the high voltage engineering, in this talk I would like to speak about the future skills and industry trends in the high voltage engineering. In fact, the high voltage industry is evolving rapidly with the new technologies and demands. Engineers need updated skills to handle HVDC, AI, and new renewable integration. The last decade has shown a clear shift from the traditional power systems to the digital grids. Industry trends are shaping how utilities and manufacturers invest in the future. In this talk, I will try to focus on skills, opportunity, and workforce trends. But why skills matter in the high voltage engineering? High voltage systems are critical for powering entire nations and industries. Mistakes or gaps in the knowledge can lead to the costly failures. As technology evolves, engineers must continuously update their skills. Employers now seek expertise in both hardware and software. Then we can say that skilled professionals are in the high demand across the global market. About the technical skills of the last decade, during the last 10 years, power electronics knowledge has become essential. Familiarity with the MMC converters and HVDC systems is now expected. Understanding of insulation science and SF₆ alternatives is critical. Diagnostics methods like PD analysis are the part of the core training. And then we can say that these skills define the modern HV engineer. There is a interesting discussion on emerging skills for the future. AI and data analytics are entering the high voltage engineering skill set. Um, Digital twins modeling is becoming a sought after capability. The cybersecurity knowledge is required to protect the digital substations. Climate resilience engineering is emerging as a specialization, and these skills will define the next generation of high voltage experts. About the industry trends in the manufacturing and supply chain, I would like to tell you that cable and converter manufacturing has expanded rapidly in Europe and Asia. Localized supply chains are being built to support the offshore wind and renewables. On the other hand, the test labs for 525 kV to 640 kV HVDC systems have opened in the last decade. Um, Workforce demand has grown in the cable factories and switchgear production. These trends create new job opportunities worldwide. About the utility and grid operator trends, I would like to tell you that utilities are adopting condition-based maintenance as the standard. AI and monitoring tools require staff with digital skills. Grid codes now require renewable developers to understand the grid forming control. Utilities invest in the training programs for the advanced HVDC and diagnostics. Skills and industry needs are evolving together. About the trends in the academia and R&D sections, I would like to tell you that universities and R&D sectors have added HVDC and renewable integration courses in the last decade. Research funding now targets insulation, HVDC protection, and SF₆-free switchgears. And on the other hand, students are expected to work with both simulation and experimental setups. However, the collaboration between the academia and industry is stronger than ever, and this is very much interesting. This ensures graduates are ready for industry challenges. About the global workforce demand, China, Europe, and the US are leading the HVDC project's deployment. Australia and India are investing heavily in the renewable zones requiring HV systems. The global demand for HV engineers exceeds supply. Engineers with hybrid skills, I mean power plus digital, are especially valued. Workforce mobility is increasing with the opportunity across the countries, across the continents, sorry. Career pathways and opportunities for the next years. Engineers can work in utilities, manufacturing, R&D, or consulting. Standard, and this is very much interesting to tell you that startups in energy storage and hydrogen also need high voltage expertise. And international projects provide career mobility and exposure. However, skills in sustainability and project management add extra value. Career growth is strong for those who adapt the, to new trends. And in conclusion, I would like to tell you that high voltage engineering has changed dramatically in the last 10 years. Skills now include the power electronics, digital twins, and AI. However, industry trends show the growing demand and global opportunity. And this is very much important, especially for startups, university, and R&D sectors to be careful about this issue. Education and industry are aligning to meet the future challenge. And high voltage engineering remains one of the most impactful careers in the energy transition. Thank you for your attention.